So I'm Philip Mielke. I'm the 3D Web Experience Product Manager. It's my pleasure to speak with you today about some of the advancements that we've made over the last year in using 3D WebGIS, utilizing WebGL. I want to go through basically an index of the improvements that you can utilize both in the JavaScript API and the out-of-the-box scene viewer, as well as some of the configurable applications that can work with it. And from there, we'll go into a little bit greater detail about some simple calls using the JavaScript API up into the point of actually building an application that has a simple set of features that come together. So I think one of the interesting things that we're noticing about WebGIS here, or WebGIS here at this point in 3D, is that it's right at that point where ArcGIS Online was when people were bumping their head up against a 1,000 feature limitation, and everybody said, well, 1,000 features, I've got way more than 1,000 features when it comes to collecting trees or water meters or all of the different things that everybody needs to be able to do. And it was a fledgling effort that was ultimately not quite useful for people to really implement into their enterprise. But when that feature limitation got removed, the usage exploded. We're at the same point now with 3D WebGIS where we've reduced the feature limitations that we have for points, lines, and polygons. So what we're seeing in the previous section was 300,000 points that was symbolized using smart mapping and shown across the United States from census data. This is 20,000 line features that are as a feature layer, not the scene layers that we'd seen before, not like a cached set of data that would then be rendered in WebGL. This is actually feature layers that are symbolized using smart mapping so that you can represent them, you can represent changes, you can set refresh intervals, and you can basically use your existing, typically 2D authoritative information and represent it within 3D. So the removal of feature limitations for lines and for polygons here in this case just came last December. So people are starting to figure out how to work with it and find ways to use it. This is an example. The state of Florida shares building outlines for all of the buildings, and these are some simple extrusions that are showing that you can use those polygons and represent them in 3D space. The other end of this here too, if you wanted some greater detail, is to use the local government base map solution in order to extract heights and roof forms from LiDAR data. It's one of the ways to help people get started a little bit more quickly. A lot of this comes from performance improvements, and so what we're seeing here is symbology scaling and integrated mesh. So if you take a close look at these trees here, what you'll see is 3 levels of details for these points that are representing trees. And as you look very closely, you'll see the shape of the trees change. You can see the shadow affected here. It's kind of hard to see with but this is really representing a mechanism that we're using in order to improve performance using web styles. Web styles are something that you can create your own, or you can use the over 100 individual models that we end up sharing on ArcGIS Online and Enterprise for you to be able to represent things like trees, street furniture, and all the common things that we're asked about. We're looking at making some improvements, so if you have any suggestions, let us know. This is an example of integrated mesh. So we have some partners in this space that produce city-wide integrated meshes that can be used to help to represent reality in a way where you can do measurements and start to understand some things like exploratory analysis tools for line of sight. This is Boston, and this is something that a company that we were working with was able to produce within a 24-hour period for a priority customer engagement. So it's interesting what some of these partners are able to do with this data. I'd be interested to hear if you're doing some of the same things with integrated mesh. We're seeing that a lot more being served through WebGL in the scene viewer. One of the greatest things here too about going new places is the ability to be able to access web scenes on mobile devices, and the experience is actually quite nice. It's a little better than this, but when it loads, what you'll be able to see when this GIF is that working on a mobile device is an intuitive process that, well, on a touchscreen device, you can zoom in, you can move, and it's a natural way to engage with the scene. So I recommend you take a look at some scenes on a mobile device if you haven't gotten the chance to see it yet. Another example of going new places is the building scene layer. So one of the things that we've done is to have Revit as a data source in ArcGIS Pro, where you can then share that as a building scene layer. And so with the building scene layer here at this point, what you'll see as we move closer to it is that you're able to take a very complicated CAD-based model in Revit and start to tear it apart in a web scene. You can share multiple BIM data through building scene layers in a scene, so that you can, say, walk through a story map just like that, representing very great detail of all of these buildings. Something that our customers have been asking about, and some improvements that we've made with that. And so get a hold of some Revit data, give it a shot, publish it from Pro, and get it into a scene and see what you can do with it. Another example of going new places is the ability, 2018, we've enabled how you can actually navigate underground or add transparency to the ground, so that you're able to see utilities underground, or you can actually start to navigate underground in order to be able to pull out some features like utilities, or in this case, this is seismic activity around well bores. So it's a great chance to be able to, well, start to understand how groups like natural resources, utilities, geology groups are beginning to work with this data in a little different way. And they want to find new places that they can start to represent GIS data. So new experiences within 3D WebGIS, what we'll see are some the ability to be able to work with some components. I was mentioning the building scene layer. There's a tool here called the Building Explorer. And basically what that does, the building scene layer is a very specific set of schema that enables you to break down the disciplines and categories of a Revit model, and then be able to work through these standard data types and really break a building apart according to those disciplines and categories. This is another example of the Slice tool, something that was also recently added into the Scene Viewer and the JavaScript API, that gives you the ability to be able to cut through numerous pieces of layers, or you can remove layers from the slice, so that you can just expose components. Like you can take a building across and just expose the piping or the HVAC systems. It's really interesting. Filtering, this is an example. You can do field-based filtering, and so in this case, this is a classification code on LiDAR, where we're stripping out all the vegetation and exposing a transmission line based off the classification on that LiDAR data. Something that can be do, it's a simple version of filtering. You can do more complex filtering using the JavaScript API, but it's a nice thing to be able to consume out of the box. There's a search feature in Scene Viewer where you can point to fields and features, and it's a great way to be able to navigate to components that sometimes, especially some of our executive users, have a difficult time trying to get from point A to point B in a scene. Starting to work with 3D is a little bit of a difficult thing for people at the first time. So things that can help people represent what's like 2D moving to 3D are a bit more helpful for this. This is a great example of how to actually do this. This is a scene with Inset Map. It's a new web template that we've shared where you can point to a web map, and you can see here very closely is that there's a web map that we're referring to as we're navigating a space-time cube, so that you can really give your users the chance to be able to really orient themselves according to what their typical 2D environments are. You can expand this, you can interact with the inset map in order to place that scene as well. Similar kind of effort here is the Compare app, where you can compare web map to web map, web map to web scene, or two scenes. And it gives you the chance to load these scenes. And in this one, this is an example of being able to look at peaks in the San Bernardino Mountains, where we're able to see these peaks and then have the representative web map depicting slope values on the right-hand side. So it gives us really the opportunity to be able to confirm that what it is that we're seeing, how we're seeing it, and go for greater contextual detail. One of the requests that we're getting from our customers as well is to reach a little bit more parity with what the web map experience is. A lot of our GIS users who've been working with ArcGIS Online for a very long time have understood and started to work through mechanisms of behavior for things like building web maps. And so this is an example that we've improved the scene viewer add data dialog. So in the scene designing experience, as you're walking through and creating your own web scenes, this is a smoother way to be able to filter on where the content is coming from, what are tags that are associated with it, and to be able to sort by like date modified and other things. It's a great way to improve how you're working within the web scene. So one of the final components here is, as we made some improvements here, is actually the ability to add your own style. So this is a web app that is showing an example of some of the styling choices for edges that can be made natively. And you can access this using the JavaScript API or directly edit this within scenes. So you can you can use things like the sketch style, which is a great way to be able to say, to focus on a specific building or a plan, and then to be able to sort of reduce the focus on all the other areas. It's a great way to be able to differentiate plans, or to just really change some of your thematic choices when you're creating a map. This is an example here of adding your own styling for the background. So typically, if you open a global view of a scene, you end up seeing all the stars and the atmosphere and everything else that's associated with it, which if you wanted to embed a globe like this in a blog or another kind of application, you may want to simplify things. So this is a great way to be able to reduce all of the extra noise that's happening behind the scenes and get a closer look at some of the data that you're trying to focus on here at this point. So that's the example of adding your own style. Just an aside, there's a little bit more that as far as some of the improvements that we've made, one of the fun things is the ability for navigation, and so how you can use a gamepad, or you can use a space mouse. Does anybody have a space mouse, or have you worked with a space mouse before? This is one of the that's one of the requests that we've gotten for navigating through a scene. A lot of CAD developers, drafters, those that are, or even in the design industry, have really started to use Space Mouse as a standard. And when I first saw it, I was like, nah, I don't know about that. And then I used it, I'm a believer. It's a great way to be able to navigate X, Y, and Z, change your rotation and your pitch so that you can really take a closer look at the things that you'd like to, and it's responsive in terms of how far you push it, how quick it goes. It's a great way to start working in 3D. If you have an interest in it, I recommend you check it out. So what we're going to show next are some examples of utilizing the JavaScript API. Arno has just joined Esri here as a part of our Zurich R&D team, and he's our JavaScript API evangelist for 3D. So thanks, Arno.
That's it. Thank you very much. I'd like to go through a few examples. I hope you can hear me. Oh, this is better. So the examples, you can check them out yourself. They're on GitHub. Is this loud enough?
Just check.
They're examples that could be used by a local government to basically communicate information, work on use for planning, directly using the JavaScript API. The samples we're going to go through, so they are actually live. I hope the internet is not going to let me down, just like before. So what you see on the right side is an actual map rendered live. On the left side you have the code for it to basically show what you have to do the same. So this is really all we're doing on the left side to render inside the map. So we're basically starting off with a map that looks like a 2D map, but in fact we're instantiating it using a scene view, so we can zoom in, we can tilt, and add some elevation layers so we can actually see the mountains around. And by adding a few data layers, scene layers, we actually get buildings, streetlights, and trees into our scene. So with a few lines of code, we already have Redlands in this example populated with quite a few 3D objects. I'd quickly like to talk about geometries. They play an important role in using the JavaScript API. You see I'm initializing a polygon at the top, providing latitude, longitude. values. Once we have that, we can use it to navigate just as before. Instead of providing a camera position, we can just provide the polygon. The scene view will automatically rotate and zoom into that polygon. In the next step, I'm adding it as a graphic, giving it an orange fill onto the ground, so you can actually see the polygon. And in the third step, I'm applying it to a feature filter. That's a new feature coming out in the 4.11 version, where you can basically say, hey, everything that's inside or outside that polygon is filtered. In this case, we simply use it to remove that building. So what can we do with this empty space? One possibility is adding a building scene layer. This is one of Esri's administrative buildings on the campus. And what do we get by using a building scene layer? So it actually gives us an API to directly access these layers that Phil talked about before. And in this case, what I'm doing is simply removing the visibility of those layers. So in the first example, we're removing the walls. And then in the second step, we're also removing roof and windows.
Just as a reminder, the creation of a building scene layer is something that happens. ArcGIS Pro consumes Revit as a data source, and then you publish that building scene layer directly from Pro. It's a new kind of scene layer type that's meant to optimize the experience for viewing and working with buildings. This one's not quite so big, but when we end up finding some of our customers pushing skyscrapers through, you need to find a mechanism to be able to optimize that data. Building scene layers are our best approach at that, and it's something that was released in our December update as well.
The nice thing about the API, you don't have to code everything yourself. It does come with a bunch of widgets, and also view models for those widgets. So in this example, I'd like to show you a few of the basic tools we have inside the API, for example, for measuring. So if you wanted to interact with this building and find out certain metrics about it, like the height of the roof, there's simple tools you can add to your scene and invoke them. There's also an area measurement tool. So if you wanted to know what the area is, you can basically select these points. Another tool we've seen before already, the slice tool, where you can basically look inside the building by removing certain layers, but also saying, specifying which layers you would like to keep. Something I really like about these tools is they work on a very small scale, like we've just seen, but you can actually use them on a global scale as well. When you zoom out and you basically point this location anywhere else, if that's something you would want to find out, then it takes basically the shape of the globe into account. So you do get the correct distance from wherever you measured. So besides looking at the building and the different layers, we're still in the same scene here. We added a satellite base map. One of the features, as already mentioned, is the underground. In this example here, we're adding a feature layer with a bunch of pipes. And usually navigation is constrained to above ground, but you can turn that off in order to move underground and have a look at what's going on there. Specifically to, what happened there? Yep. Specifically to have a closer look at some of the geometries. In this case, you see the water pipes being above the sewer, which I guess is a common way of doing it in case of any leakage. I'd quickly like to cover some of the rendering that we provide in the API, which is quite nice. So in this case, we have a bit of a gray sky. I heard California's been having some hazy weather lately, but actually in this example here, it's really just a gray background we have. and we turned off the atmosphere. So if we do turn that back on, you do actually get a clear sky, and you can set things like the daytime and shadows, and it will render correctly in the scene. I hope you can see this on the beamer. So besides that, you can actually also play around with animations, and in this case we're simulating a sunset. So you do have the sun, and eventually you do see the stars, and I've been told that the stars that you see, they are actually correct. So those are the correct star patterns, as if you would look at the sky at that time of the day. So a little more about rendering. Going back to our scene, we're still at night. We're putting back the buildings in. We have a gray base map, so everything is a bit dark. If we wanted to light that up so you can actually see something at night, there's different possibilities of changing the rendering. In this case, we're changing the render of the buildings to give it a white outline and a transparent facade. So you can hopefully see that a little better also on the beamer. Besides that, one of my favorite features are the VectorTile base map, which you can also use in the API. In this case, in this example here, we're setting the JSON directly, defining all the different colors for different features inside the VectorTile maps layers. Excuse me. I would have, however, recommend that you do go and use the VectorTile editor that we've seen in the plenary instead of trying to edit those values yourself. There are thousands of entries for all of the features that you have in a vector tile layer. So this gives us a little more of a night view. Something you could possibly use, for example, if you did some night navigation. Or, as we'll see in the next slide, we're looking at one use case where we're basically trying to visualize tactical operations on the campus of Esri in Redlands.
So as night falls, we change from one department in a municipality, concerns about development plans, to public safety. I used to work with a dispatch department, or a dispatch in Redlands Police Department on a pretty frequent basis. And this is an example of utilizing one of our existing solutions here, the Tactical Operations Planning Kit. Solutions, if you haven't seen them, are a great way in which to be able to implement schema and symbology that are consistent for each of the industries that we serve. It reduces the amount of time. Nobody needs to reinvent the wheel. It's a great place to start, but moreover from there you can configure off of the starting ground for what this is. So in the case of the Tactical Operations Viewer, it was something that was planned for typically two-dimensional workflows. A nice thing about this is that you can incorporate your feature layers as they're in 2D into 3D and start to look at different ways in which you can symbolize them or just utilize them outright. There is no changes to the way that we approach these features here, other than bringing them in and representing them within this web scene. And as you make changes or as you update those values and edit them from two-dimensional web map editing experience, that then propagates to the 3D web map here. So in the case of being able to ensure that we're following activity through, say, GeoEvent, the server rule, and we've got AVL data that's coming through, that also enables you to be able to contextualize with that solution, but then also follow the plans of the assets that you're tracking, and then ultimately be able to further contextualize what happens within the scene by using the track command here in order to follow this point here that we're simulating within this view. So it's a great way to be able to bring further value using 3D as context, and also leveraging the investment that's been made in your customers' typically two-dimensional GIS experience, and bring that into 3D with greater visibility and new forms of data and analysis that they can incorporate into it. So I urge you to check this out. This is our last slide at this point, and I think we've got 5 more minutes for questions then, if you've got any questions that we can answer for you. Any questions? Well, enjoy the rest of your day. Thank you for your time with us. Please, we encourage you to take the survey, and if there's any other way we can help you out, we'll be both in the JavaScript API area and the 3D island. Thanks very much.
Thanks, everyone.